Welcome to another edition of prosoft-technology video training. The Siemens Industrial Ethernet Multi-Client Enhanced Communication Module allows Rockwell Automation ControlLogix programmable automation controllers to easily interface with multiple S7 CPUs, including the S7-200, 300, 400, and 1200. In this video, we're going to cover the process for configuring the NVI56E SIE module and setting up a project in RSLogix 5000 that will allow a ControlLogix processor to read and write data to Siemens S7 CPUs. I'll give some examples of communication with an S7-200 and an S7-300. With the NVI56E SIE installed in the ControlLogix chassis, I'll open RSLogix and create a new project. When the new controller window opens, I'll select my controller type and revision number, give it a name, and select the chassis type, which in my case is a 4-slot 1756. My controller is in slot 0, and I'll click OK. Once the project is created, I'll expand the I/O configuration in the controller organizer, right-click on the 1756 backplane, and select New Module. In the Select Module screen, expand Communication, and I'll select the Ethernet Bridge module that I have in my rack, and EN2T. And click Create. I'll give the module a name and enter the IP address. And when I'm done, I'll click OK. So now I'll bring in the NVI56E SIE module, right-click on the backplane and select New Module again, expand Other, and choose a generic 1756 module. In the new module window, name it SIE, and I can also add an optional description here. It's important to set the COM format to data int so that the module can communicate over the backplane. The slot number should be the slot the NVI56 SIE actually occupies in the rack, and the connection parameters should be set up as I have them here. So once you have all this, click OK. Now I'll edit the module properties. The requested packet interval value represents the minimum frequency at which the module will handle scheduled events. So this value should not be set to less than 1 millisecond. The default value is 5 milliseconds, and that should work for most applications. I'll just leave it at the default value. So click OK and save the project. Now I'll import the add-on instruction. A copy of the AOI file for the SIE can be found on the DVD that comes packaged with the module. And you can also download a copy of the AOI file by going to our website at www.prosoft-technology.com. And in the controller organizer window, I'll expand Tasks, Main Task, and Main Program, and double-click on Main Routine. Once the main routine opens, I'll right-click on Rung 0 and select Import Rung. Then I'll browse for and select the add-on rung file and click Import. When the import configuration window opens, I'll change the slot number by modifying the local :slot number field to match the number of the slot that the NVI56E SIE is actually residing in. In this case, I have the module in slot 3 of the rack, so I'll change each field to slot 3. Then delete rung 0. Now, the user-defined data types imported with the add-on rung are now listed in the data type section of the controller organizer tree, which you can see here. Now our configuration for the SIE should be ready to download. So I'll go up to communication and select Who Active. And on the Who Active screen, I'll look in my Ethernet connections and locate the Ethernet module in the ControlLogix rack. Open up the backplane and select the processor and click Download. And click Download again on the download screen, and the CPU will receive the configuration. And once the download is complete, we're given the option to place the controller in remote run mode, and I'll do that. Now if the option doesn't come up automatically, you can simply go over to the controller status bar, be sure that you are in fact online, and then just select run mode. Alright, so that does it for this stage of the configuration. The next task is to configure how the module will communicate with the Siemens S7 controllers. So to do this, I'll open up ProSoft Configuration Builder, and with the new project, I'll add the NVI56E SIE module. So select Default Module in the tree view, right-click to open a shortcut menu, select Choose Module Type, which opens the Choose Module Type dialog box, and under Product Line Filter, select the NVI56E, and in the Select Module Type drop-down list, select the NVI56E SIE, and then click OK to save your settings and return to the ProSoft Configuration Builder window. So you can see that the configuration pane now has a long list of SIE clients. This is a good time to give names to the project and the location. I'll begin by clicking on the plus sign next to the icon to expand module information. Then double-click on the icon to open the Edit dialog box. To edit a parameter, select the parameter in the left pane, make your changes in the right pane, and click OK to save your changes. The first thing we need to do is set a temporary IP address so that we can access and configure the module. So to do this, we'll go to the shortcut menu, right-click on the module, and choose Diagnostics. This will open up the Diagnostics dialog box. Click the Setup Connection button to bring up the connection setup window. With Ethernet set as the connection type, you can click the Test Connection button to see if the path to the module is available. But unless your subnet happens to be the same as the module's default IP, you'll get back an error saying that PCB couldn't connect to the IP address. So if that is the case, you would click Browse Devices, and this will open the ProSoft Discovery Service. Select the module, then right-click and choose Assign Temporary IP. And choose an unused IP within your subnet, and then click OK. The temporary IP will allow us to connect to the module and download our configuration by overriding the default IP address. The reason it's temporary is because the next time the module reboots or power cycles, it will revert back to the default IP. So we need to set a permanent IP address. To do that, close these windows and go to the Ethernet settings under the module, double-click, and enter an IP address that your network administrator gives you. If you don't know your subnet, you can just zero that out. I'll go over the database configuration now. By default, the read registers start at 0 and there's a count of 600. The write registers start at 1000, also with a count of 600 16-bit words. The 600 counts are just the default values. You can make them bigger or smaller to suit your requirements, and you can move the start registers wherever you like inside the NVI56E SIE's 5,000 word database, so long as they don't overlap. To make changes to the configuration, you just expand the Module tab and double-click on the Edit Module tab. And if you do change anything, you'll have to go back into RSLogix and change the configuration there accordingly. I'm just going to leave the settings as they are. In order for the module to use the settings I've just configured, I have to download the updated project file from my PC to the module. In the tree view in PCB, click on Project from the top menu bar. Open the Module menu and select Download from PC to Device. This will open the download dialog box, and notice that the Ethernet address field contains the temporary IP address that I assigned in the previous step. Prosoft Configuration Builder will use the temporary IP to connect to and configure the module. Click Test Connection to verify that we're connecting to the module, and if the connection succeeds, click Download to transfer the configuration to the module. The module will reboot using the new configuration, and it will now be set to the permanent IP address. Now I'll create some commands for the module to allow my ControlLogix processor to write and read data to and from a Siemens S7-300 controller. In Prosoft Configuration Builder, I'll expand SIE Client 0 tab and then double-click on the SIE Client 0 Commands tab. In the window that pops up, I'll add a row and then edit that row. Then in the Edit Row 1 window, I'll enable the command, set the internal address to 1000, which is where the module's write data begins. Leave poll interval at 0, set the reg count to 5, which will write 5 consecutive registers to the S7. Next, I'll enter the IP address of the S7-300 processor that I'll be writing and reading commands to. I'll pick the PLC type, enter the slot number of the Ethernet card in the S7 chassis, which for me is slot 2. I'll set the function type to write, data type to int, and address type to dB, and set the dB number to 1 and address to 0. Now that should do it for the write command. I'll click OK to exit the Edit Row 1 dialog box. Then back in the SIE Client 0 Commands tab, I'll add another row and edit that row. And this is going to be the read command. So as before, I'll enable the command, leave the internal address at 0, which is the starting location of the read area of the database. I'll set the reg count to 5. Enter the IP address, the PLC type, the rack and slot number, all the same as before. The function type will be read, and I'll set the data type to real, and the address type to flag. I'll click OK, and then OK again in the Client 0 Commands tab. Now I can download the new configuration to the ControlLogix processor by right-clicking on the MVI56E SIE module icon and selecting Download from PC to Device from the list, and then click Download. The module will reboot with the new configuration, and when it's done, click OK. Now, back in RSLogix, expand the SIE.control structure. And here, I'll enable the two commands by placing a 1 in both SIE control.command-control.write command bits 0.0 and 0.1. These represent the two commands that we just created in Prosoft Configuration Builder. While I'm here, I'll go ahead and enter some values into the write data controller tags that the write command I set up in Prosoft Configuration Builder will write over to the S7 processor. So I'll expand SIE.data.writeData and enter some values in SIE write data 0 through SIE write data 4. These values should appear in the database of the S7-300 processor, which I have set up and online already. I'll open the variable table in Semantic Manager, and I can see that the values that I entered in RSLogix are coming through. Now I'll test the read command for the SIE module. I have some status values here. I'll jump back to RSLogix and expand the SIE.control list. I already enabled the command, so the data from the S7-300 should appear in the controller tags SIE.data.readdata 0 through 9. And here's the data. Now, since the read data is an array of integers, it doesn't appear in floating point format. To see it in floating point format, there are a few steps I'll need to take. I'll need to copy it into an array with a real data type. So click the Edit Tags tab at the bottom of the window and enter a name for the array. I'm just going to call it real data. And then in the data type column, enter real bracket 5. Now I'll add a copy instruction to the main routine ladder. So I'll add a rung, right click, and then add a ladder element, and then under File Miscellaneous, I'll select Copy. So the source for the instruction will be 10 words from SIE data, read data, and the destination will be the real data array that I just created in the previous step. And then the length of the COP instruction here is the length of the destination. Since 10 integers or 10 words becomes 5 floating point numbers, the copy length is 5. I'll accept the rung edit. And I'll check to see that the data transferred from the S7-300 processor is appearing in real data 0 through real data 4 in floating point form. And there it is, and there you have it. And that's just a quick example of how you go about moving data through the NVI56E SIE module from the S7-300 processor to a ControlLogix processor. Now I will create some commands for the module to allow my ControlLogix processor to write and read data to and from a Siemens S7-200 controller. In PCB, I'll expand the SIE Client 1 tab and then double click on the SIE Client 1 Commands tab. In the window that pops up, I'll add a row and then edit that row. So in the Edit Row 1 window, I'll enable the command, set the internal address to 1005, which is where the module's write data begins, plus the 5 registers that I've already used for the S7-300 command. I'll leave pull interval at 0, set the reg count to 5, which will write 5 consecutive registers to the S7-200. Next, I'll enter the IP address of the S7-200 processor that I'll be writing and reading commands to. I'll pick the PLC type. I don't need to enter a slot for the S7-200. And by default, the TSAP will be 1000. Now, if your processor's TSAP has been set to a different value, then you should change it accordingly here. I'll set the function type to write, data type to integer, address type to dB, and then the dB number and address can just stay the same. That should do it for the write command. I'll click OK to exit the Edit Row 1 dialog box. And back in the SIE Client 1 Commands tab, I'll add another row and edit that row. This is going to be the read command. I'll enable the command and set the internal address at 5, which is the start of the read area of the module's database, plus the 5 registers for the S7-300 command that I already assigned. I'll set the reg count to 5, enter the IP address, the PLC type, and the TSAP number, which are all the same as before. The function type will be read, and I'll set the data type to real and the address type to flag. And I'll click OK, and OK again on the Client 0 Commands tab. Now I can download the new configuration to the ControlLogix processor. So I'll right-click on the MVI56E SIE module icon and select Download from PC to Device from the drop-down list, and then click Download. The module will reboot with the new configuration, and when it's done, I'll click OK. Now, back in RSLogix, expand the SIE control structure, and here I'll enable the two commands by placing a 1 in both SIE control, command control right command bits, bracket 1 0 and bracket 1 1. These correspond to the SIE client 1 commands that I just set up in PCB. So I actually already have all the commands enabled here, but by default they're disabled. While I'm here, I'll go ahead and enter some values into the write data controller tags that the write command I set up in Prosoft Configuration Builder will write over to the S7 processor. So I'll start by expanding SIE data write data and enter some values in SIE write data 5 through SIE write data 9. These values should appear in the database of the S7-200 processor, which I have set up and online already. You can see the variables from RSLogix appearing in the current value column. So the write data values that I entered in RSLogix were transmitted successfully. Now I'll test my read command for the SIE module. I have some values entered in the S7-200 here. So now I can jump back to RSLogix and expand the SIE control list. I already enabled the command, so the data from the S7-200 should appear in the controller tags SIE data read data bracket 5 through 13, or actually 5 through 14. And there it is. And that's how you go about moving data through the MVI56 SIE module from the S7-200 processor to a ControlLogix processor. For more information, visit our website or give us a call. Happy training.